Okay, let's get started. Let me have your attention, please. Let's get started. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker, who is Mr. Alex Gabbard, who is a retired staff member of the Oak Ridge National Laboratory. Alex received a BS in Mechanical Engineering and a BS in Physics from NC State University in 1974. And then he received an MS in Physics, also from NC State, in 1979. He joined the Oak Ridge National Laboratory in 1980, and he's been there for the past 25 years, working in the area of fusion energy primarily. The title of his presentation today is Cold War Weapons and Historical Perspective from 1946 to 1991. So ladies and gentlemen, please welcome Mr. Alex Gabbard.
Hello, thanks for the invitation to give you a little talk today. What I'm going to do is to give you a perspective from the distant past. Everything that you'll see in this presentation preceded 1970, involves my involvement with the United States Navy and an organization you've never heard of, the Defense Atomic Support Agency. It was a period in time of the Cold War involvement between the United States and the USSR, and there was a small group of us guys who were highly trained warhead experts. I was what would be described as a top boomer. You've heard the word boomer associated with the Fleet ballistic missile submarines. The reason that they were called boomers was called the warheads that's on the ends of their missiles. There was groups of people that took care of those warheads. They were us. We were the boomers, and those of us who had a top secret clearance were a top boomer. So that's a little bit of perspective. In the upper left-hand corner is the cover of my latest book, which goes into this story, Adventures of an H-Bomb Mechanic, the story of a top boomer. Now you know what that means. The lower left-hand corner is the Navy Nuclear Weapons Association, Keepers of the Dragon. That's us guys who did this kind of work. We've maintained an organization over the years. Well, we all know that a new type of warfare began in August of 1945. The physicist, a university professor who took over the program from the University of California, Robert Oppenheimer, stood and watched the blinding white flash from the New Mexico desert and stated in the upper right-hand corner, "I am become death, the shatterer of worlds." That's from the Bhagavad Gita. At the bottom, I'm not sure you can read this, so I'll read this for you. Hans Bethe was a physicist who was involved in the A-bomb and the H-bomb projects at Los Alamos. He says, "If we fight a war and win it with H-bombs, what history will remember is not the ideals we were fighting for, but the methods we used to accomplish them. These methods will be compared to the warfare of Genghis Khan, who ruthlessly killed every last inhabitant of Persia." In the background is one of the Pacific Ocean tests. This is Bravo. Keep that name in mind. You'll see this later on as we go through this. Okay, August 1945, the beginning. I'll give you a brief background survey. Gadget, that was the Trinity test of Alamogordo. Little Boy was the Mark I in terms of warheads. That was the first one. That was Hiroshima. It was a 16 kiloton warhead. Fat Man, is used in Nagasaki, was called the Mark III. It was a 20 kiloton. This was no more than the gadget in bomb form, that is, in a casing that could be dropped from an aircraft. World War II soon ended. The Cold War began. The United States, the world's only nuclear power until 1949, faced off against the USSR, soon to challenge. And the reason for that was Dr. Klaus Fuchs, who was a British physicist at Los Alamos, wrote 2 copies of each of his reports. one for his U.S. supervision and one for his KGB contact. Joe 1, that was the first Soviet blast in 1949, was identical to the Gadget. Fuchs did his work well for the Soviet Union. This is the Gadget. Get a perspective of size. This individual standing or sitting behind. This is in the tower just before it erupted. This is the Trinity blast. 6 thousandths of a second. It was something over a meter in extent. Within a tenth of a second after that, it had doubled in volume. What you see out here is a Joshua tree about to be consumed in the blast. This is the Little Boy. This was a uranium gun type weapon. This was dropped on Hiroshima from the Enola Gay, August 6, 1945, early in the morning, 8:15. All that's a matter of history. This is what it did. This was Hiroshima after 16 kilotons. Fat Man was the Gadget in bomb form. This was what was dropped on Nagasaki, 11:02, August 9th, 3 days later, 1945. Shortly after that, World War II ended. The only aircraft in the world at the time that could deliver a bomb of the weight of Fat Man was a B-29 long-range bomber that had been developed during World War II. Its range was 4,100 miles. It could carry 20,000 pounds, one bomb. This was the first nuclear-capable aircraft. The Cold War, where did that phrase come from? It was coined by journalist Walter Lippmann in response to a 1947 article in Foreign Affairs. The title of the article was The Sources of Soviet Conduct, written by George F. Kennan. We have adopted Cold War as the period of time. That article appeared in July 1947, the month that the United States Air Force was established. There were already many things underway by that date. The post-war period, since I can't see the screen, I'm going to have to catch up. Yeah, just that side. You can turn it towards me just a little. Yeah, that's good right there. Can everybody else see that okay? Okay. All right. Great strides in physics, mathematics, engineering, and computing launched an arms race that continued for decades. Rapid advances were, from the engineering standpoint, rapid advances were achieved in radar and detection in the atmosphere, surveillance and detection in the oceans, and many military technologies that set personnel needs. Where did these people come from that did this work initially, immediately following World War II? Many of the personnel needs were satisfied by Project Overcast, Project Paperclip, and Project 63. These projects brought over 650 German specialists and their families to the United States. The Combined Intelligence Objectives Subcommittee, CIOS, kept files on another 5,000 German scientists. The Office of Technical Services, OTS, worked with the Field Information Agency Technical, or Fiat, in Germany to sponsor representatives of the United States industries who made over 3,000 recruiting trips to Germany. The recruiters gathered industrial information, samples of technology and equipment, and the U.S. microfilmed German scientific records that were disseminated to military contractors. Project Apple Pie used former German military personnel to assess the state of Soviet industry. Project Panhandle paid former German intelligence personnel to continue gathering information on the USSR. Project Credulity continuously tracked German scientists still desired for U.S. industry. Project Echo was a plan to find German scientists dispersed in Eastern Europe. Project ESSO was a study to move another 1,500 German scientists and engineers to the United States. Over half the German scientists held PhD degrees and worked in many U.S. military industries that produced, in some cases, rocketry. NASA, we're all familiar with Werner von Braun and his team and their involvement in the ICBM development. ICBM means Intercontinental Ballistic Missile. Phased Array Radar Raytheon Industries. This was crucial for tracking rocketry and is still in use today. Military Missile and ABM Systems, Avco is one of the industries, and many other contractors. And High Altitude Biodynamics, Air Force School of Aviation Medicine was established at this time to pursue many studies that were involved in the new scientific R&D agencies that were formed, such as the Air Research and Development Command, National Advisory Committee on Aeronautics, that's the NACA, that later became NASA, the Civil Aeromedical Research Institute of the Federal Aviation Administration, and U.S. Navy sister institutions. In March 1946, General Carl Spaatz, who was Chief of Staff, directed the War Department to separate the Army Air Force and set up three branches of the U.S. Air Force commands. One was the Strategic Air Command, or SAC. The Air Defense Command and the Tactical Air Command were the other two. In a short time, the Air Materiel Command was added in October 1947. Along came the Air University, Air Proving Ground, Air National Guard, Air Research and Development Command was added after 1947. So you can see that there was a tremendous emphasis placed on aeronautics and the development of aeronautical engineering. Air power emerged as the primary military force of the future. It received increasing funding during times of federal post-war cutbacks. The emerging technologies were jet engines and jet-powered aircraft, aerial refueling, growing interest in space, that is above the atmosphere, and rocketry, need for many new technologies, such as Mach 1 plus human studies, high-altitude surveillance, advanced communications, photography, and many other fields. In the background, rapidly advancing atomic weapons, that is, advances in R&D on thermonuclear, that is, TN, which I'll use throughout, which equals H-bomb, warheads, established delivery capability needs, and personnel needs. In August 1, 1946, President Truman signed the Atomic Energy Act into law. It established the Atomic Energy Commission, the AEC, as the civilian control over atomic energy in the United States. The Military Liaison Committee, or the MLC, was formed to interface between the AEC and the Department of Defense at the policy level. December 31st, 1946, Secretary of War Robert Patterson and Secretary of the Navy James V. Forrestal formed the Armed Forces Special Weapons Project, that is the AFSWP, ASWEPS, to handle development and deployment of nuclear weapons. AFSWEPS, I have difficulty saying that to this day, later became the Defense Atomic Support Agency, DASA, of which I became associated with. Later on, it became the Defense Nuclear Agency, which exists today. July 1947, the National Defense Act formed in tandem the United States Air Force, the Department of Defense, which was the ex-War Department, the National Security Council. As a result of this strategy, the National Security Council became the primary issuer of foreign policy statements in the 1950s. SWEP took over management of Los Alamos Z Division operations in Albuquerque, forming Sandia Base, adjacent to Kirtland Air Force Base. It expanded the Sandia Base for production, testing, and deployment of nuclear weapons, set requirements for engineering and construction, and handling the sites designated as Q areas. They were built and operated on a national and an operational, let me start this one again. They built and operated national and operational weapons storage sites in the U.S. and internationally. In October 1948, General Curtis LeMay, who was commander of the Strategic Air Command, established military control over nuclear weapon deployment. The Q areas were weapon depots in support of the Strategic Air Command nuclear bombing missions under rapid development. There were two types of Q areas. Operational, these were protected nuclear weapons storage sites near bomber runways. The national sites were assembly test and storage sites as main stockpiles. The national sites adjoined or were contained within larger military reservations. They were guarded and run independently of the host reservation. That is, they answered through the chain of command to NASA, to DASA that is, to the War Department of the Pentagon and to the President. The host military site, such as an air base, was run through the command of whatever that military branch was. The national sites were Manzano Base, attached to Kirtland Air Force Base in New Mexico. Site B was Clarksville Base, adjacent to Campbell Air Force Base on the Tennessee-Kentucky line, just north of Nashville. Site C was the Medina Base, adjacent to Kelly and Lackland Air Force Bases in Texas. Site D was Killeen Base, adjacent to Gray Air Force Base and Fort Hood in Texas. Site B achieved operational status first in 1948. Sites A and C were operational in 1949. The U.S. policy at the time assumed sole possession of atomic bombs and lead in long-range aircraft and avionics led to initial plans to delay implementation of post-war military structure. Only network radar and control implementation advanced. Late 1947, the USSR announced its Tu-4 long-range bomber, which was, in effect, reverse-engineered from 3 US B-29s captured in 1944. U.S. response was Project Supremacy. This was formal post-war air defense plans. In February 1948, USSR overran Czechoslovakia. Estimated number of operational Tu-4 bombers at the time were 200. That represented a terrific international threat to policymakers within the United States government. In March 1948, the National Security Council issued NSC 7, taking a hard anti-Soviet stance. The Air Force went on its first Cold War alert and began air defense war gains in the Pacific and Alaska regions. Now, a sequence of events that occurred very rapidly that shaped international foreign policy. In June 1948, the USSR blockaded Berlin. July 1948, President Truman sent B-29s to Europe. January 1949, modifications were completed on 60 of the B-29s for A-bombs. August 29, 1949, the USSR exploded its first atomic bomb. That's Joe 1. Now, I've taken you back to where we were a little earlier to fill in some of the blanks of what was going on in the background. In September 1949, the Communist Army overran China. October 1949, design of aircraft control and warning radar stations was completed and site construction began. The B-29 with a range of 4,100 miles and the updated B-50 with a 4,600 mile range were deemed insufficient. You'll see why they were insufficient shortly. Convair was contracted to build the B-36. It was much larger than the B-29, had a range of 10,000 miles, and it was capable of carrying the first generation hydrogen bomb. Key to the SAC mission were the Armed Forces Special Weapon Project Q areas. Now, I went through, remember, there were 4 national sites and 9 operational sites, 13 during this period of time. Under design by the engineering firm of Black & Veatch and in construction since 1946. The 4 national Q areas were warhead service depots managed by the AEC. The forward Q areas at the SAC bases, this would have been the other 9, were alert aprons managed by SAC. The warhead fabrication operations at the time were put in place at several locations. And being in this area near Oak Ridge, we all know where some of those activities took place. Now, this is an example. This shows you clearly the difference between the B-29 and the B-36. The B-36 was much larger. It had to be much larger in order to have a bomb bay to handle the first generation H-bomb, which you will see a bit later. The Berlin blockade and Joe 1 accelerated U.S. nuclear weapons delivery programs. This was the era of the long-range bomber, B-29 and B-36. In late 1947, the B-47 Stratojet strategic bomber was begun. Became operational in 1952. This was the first U.S. high-altitude, medium-range jet bomber. Had a 4,000-mile range. 2,039 B-47s were built through 1956. These planes had one objective, and that was to deliver atomic and hydrogen bombs. In 1959, 20 Q areas are operational, 13 in the U.S. Most are forward alert areas at SAC bases supplied from the 4 national depots. In 1955, B-52 Stratofortress replaced the B-47 as a main strategic bomber. 7,500-mile range, it was high altitude, and carried a larger payload. 744 were built through 1962. The first 10 years set 4 decades of U.S. nuclear weapons policy. This is the B-47 at a takeoff. It was, at the time, the jet engines were not sufficient to lift the plane, so it was assisted with the rockets in order to launch. The B-52 is still in use today. This is in Gulf War trim. In 1947, the Armed Forces Special Weapon Project had 13 atomic bombs in its inventory. In January 1950, President Truman authorized development of the hydrogen bomb. In October 1950, Truman authorized concerted expansion of U.S. nuclear weapon production. In 1951, the Armed Forces Special Weapon Project had 438 weapons in its stockpile. In 1952, it had 832 bombs. In 1953, it had 1,161. By 1955, there were 2,280 nuclear and first-generation thermonuclear bombs in the arsenal. The Air Force began development of long-range nuclear missiles at this time. Well, a missile could not carry these very heavy warheads, so there was an emphasis to make warheads smaller and lighter for purpose of missile delivery. First-generation thermonuclear warheads during the bomber era were the Mark 14. I don't have a weight up there that I can see. This was a first-generation deployable bomb developed from some of the Pacific Ocean tests. This weapon had a 6.9 megaton yield. The Mark 15 that came later was the first lightweight thermonuclear weapon. It used in highly enriched uranium secondary casing for fission, fusion, physics. If you study your physics, you'll know what that means. It's weighed 7,600 pounds. Its yield is 3.8 megatons. 1,200 were produced and retired by 1965. The Mark 17 was the heaviest U.S. weapon at 42,000 pounds. This is the weapon that the B-36 was designed to carry. It was 25 feet long, 6 feet in diameter. Its yield was 15 megatons. It was only in the arsenal a brief time and was retired in 1957 simply because it was so big. The Mark 18 was a high-yield Mark 8 super oralloy bomb. That's the SOB. Now, if you know what oralloy means, that is Oak Ridge alloy. So you know where the fuel came from for these weapons. This was a 92-point implosion, all highly enriched uranium. Its yield was 500 kilotons, or half a megaton. 80 was produced. They were replaced or designed into the Mark 15 and the Mark 28. October 1952, Britain performed its first nuclear test, and in doing so, discovered that one of its lead scientists, Dr. Klaus Fuchs, was the Soviet mole at Los Alamos during the war. That created a tremendous upheaval in British nuclear development. November 1952, the U.S. performed its first thermonuclear test. In August 1953, less than a year later, the USSR performed its first thermonuclear test. At the time, there were projections that the USSR was 20 years behind. The people who arrived at that figure were very surprised when less than a year later, the Soviet Union matched U.S. technical development. In September 1954, an interesting thing happened. 44,000 Soviet troops participated in live nuclear war games, battling through radiation zones at ground zero of a medium-yield A-bomb dropped from a Tu-4 in the southern Ural Mountains. What made this situation even worse for U.S. strategists was that Soviet and Chinese officials observed the war games together. This showed a uniting of communist ideology against Western ideologies. From 1954 to 1956, in response, the Strategic Air Command enhanced infrastructure for faster takeoffs of more aircraft with nuclear loads. 1st of December 1955, President Eisenhower assigned highest priority to ICBM, that is the Atlas rocket, and the IRBM, that's IR means Intermediate Range Ballistic Missile, that's a Thor and a Jupiter. He approved the Thor and Jupiter full production on 10 October 1957. Now these weapons, these missiles, had only one objective, that is to carry a warhead. So you can see that the enormous amount of engineering and development behind the military strategy to deliver a weapon. From 1956 to 1960, alert areas went into operation at 65 SAC bases with underground mole holes for crews and nearby alert apron queue areas that supported 24-hour alerts. That is, people on the go, ready to go, 24 hours with weapons immediately at hand. So let's do a little survey, a little background, kind of catch up, take our breaths a little bit. During the 1950s, the U.S. Cold War evolution involved development and implementation of advanced, smaller thermonuclear warheads, advanced delivery systems for strategic, that is greater than 1 megaton, and tactical, that is less than 1 megaton. That's a general, that's not a hard and fast ruling, but that's sort of the way it worked out. Emphasis was placed on radar and surveillance for advancing missile and guidance technologies. Standing alerts for air defense became the norm. There were needs for increasingly sophisticated command and control networks, accurate, high-speed collection and handling of data, ushered in the computer era for faster processing, interpreting, and rapid dissemination of data. In other words, the beginning of the internet and the GPS. There was also a need for advanced communications and broad support infrastructure. Anticipated replacement of bombers with ICBMs by the early 1960s changed nuclear policy. The SAC focus shifted to rocketry and early warning systems. The North American Air Defense Command, or NORAD, its control center in the Cheyenne Mountains of Colorado, was hardened in preparation for what was thought to be an imminent nuclear attack from the Soviet Union. Okay, so a little more background. The Strategic Air Command evolution was that they inherited the World War II overseas bases and established itself as a global military arm of U.S. policy. Planned sites for, the sites were planned for second strike capability. During this period of time, 1,000 aircraft in 1953 increased to about 3,000 by 1959. This was the height of the bomber era. Personnel grew from 85,000 to 262,000 men by 1959. The planning was for war. The Strategic Air Command organized its bases in concentric rings with are measured in distance from Moscow across the North Pole as the shortest distance. It built bases along the northern tier of the United States. These were silo bases, and as you saw earlier, the national warhead sites were all in southern states. The reason for that is they were further away from potential line of attack. The policy at the time was many dispersed nuclear sites made response to any USSR attack more probable. Emphasis shifted to thermonuclear weapons. A-bombs were retired or retained as tactical weapons. At Los Alamos, a mathematician by the name of Stanislaw Ulam and a theoretical physicist by the name of Edward Teller developed a concept. Now there's some historical controversy associated with this. Many people at the time said that Edward Teller didn't have anything to do with it. Unfortunately, Ulam died early in life, so he could not defend his participation. Edward Teller lived a long life and has subsequently become known as the father of the H-bomb. There is great question about that. What's important about this slide is you see the concept of a primary and a secondary. The primary lights off the secondary. Okay? Now, if you imagine an A-bomb, that's what this is. and the secondary is an H-bomb. Then if you had one of these over here, you almost double the yield. If you had one of those up there, and one there, and one out here, and one back there, you can see how one primary can light off a number of secondaries, and that would increase the yield stepwise. And you'll see in a minute why that is important. The USSR in 1957 launched Sputnik, proving superior rocketry and control. The U.S. responses were increased emphasis on long-range early warning and surveillance radar, expanded applications of warhead with designs tending towards smaller tactical warheads for mini delivery systems, and an escalation in rocketry systems, including launch guidance and control. In 1958, the ballistic missile early warning system was begun in Alaska, Greenland, and Great Britain. The early warning radar network became intimately connected with the ballistic missile defense. In 1958, the Strategic Air Command deployed its first Thor, that's an IRBM, then Atlas ICBM, nuclear missiles at Vandenberg Air Force Base in California. The first emplacements for Atlas and Titan ICBMs began at that time. They influenced nuclear dynamics throughout the 1950s, the 60s, or the late 50s, the 60s, and the 70s. Silos were built underground and manned around the clock. In 1960, Project Looking Glass implemented the Strategic Air Command Airborne Command and Control Unit. Also that year, the National Emergency Airborne Command Post was instituted at Andrews Air Force Base near Washington. This is an illustration of IRBMs, the Thor, the Redstone, and the Jupiter of the time. Each of these rockets involved a warhead cone. So you can see that the amount of hardware associated with the missiles far exceeded the warheads, but the missiles only had one purpose, and that was to deliver the warheads. The larger missiles, the Atlas, the Titan, and the Minuteman, these were ICBMs. In the late 50s, the United States Navy emerged as the primary deterrent to Soviet nuclear first strikes. It did it in two ways. The first was with submarines. In the late 50s, the USS Nautilus proved nuclear submarine technology. The strategic deterrent offered by submarines involved a series of nuclear missile subs that were built along with a series of hunter-killer attack submarines without silos, but with advanced stealth and detection capability. These subs were also thermonuclear weapon capable, which you will learn about shortly, with the Subroc and the Astor. These were not, technically, these were not boomers. These were not the typical sort of submarine-launched ballistic missile. These were torpedo tube-launched missiles. In November 1960, the Navy's newest submarine, the USS George Washington, put to sea with 16 Polaris A-1 missiles armed with new, lightweight, compact design Mark 47, approximately 1 megaton yield thermonuclear warheads. Take note of the date, 1960. In May of 1962, and this is before the Cuban Missile Crisis of October of that year, the USS Ethan Allen launched a live Polaris A-1 that exploded 1,173 miles downrange in open ocean within 2,000 meters of target. This was the only missile test of the Mark 47 warhead. The strategic deterrence is demonstrated with that one shot. The Soviet first strike, or any Soviet first strike, cannot avoid massive retaliation from the sea. The Polaris A-1, that was the frigate bird shot, May 6, 1962. This Mark 47 Y-1, that's yield 1, warhead with a beryllium re-entry vehicle. This was the only test of an operational ballistic missile with a live thermonuclear warhead. The missile flew the 1,173 miles as mentioned. The warhead weighed 717 pounds and yielded 615 kilotons. As an adjunct to this test in the South Pacific, the Dominic Harlem shot was a Mark 47 Y-2 test, had a yield of 1.2 megatons, approximately double. so the same delivery system could deliver twice the explosive firepower. The Polaris A-1, and notice the geometry. This is the shape of the Polaris rocket, and this is the nose cone for one warhead. This is the Polaris rocket with a nose cone for 3 warheads. And the Poseidon, which is rather similar, but a modern or an evolution of the A3. The SSBN submarines, these were undetectable nuclear threat. They were stealth from the sea. Keeping in mind at the time that the Soviet Union was developing similar sorts of hardware, but their submarines were notoriously noisy. The Navy emerged as a primary deterrent for Soviet nuclear first strikes on a second front, and that is with aircraft carriers. The USS Forrestal became fully operational. It was launched in 1955. Ship was the first of the super carriers. It was fully operational in 1957. It was deactivated in 1993. A series of super carriers was built, both conventional and nuclear powered, for far-ranging show of force and surveillance with forward nuclear capability. I served on the USS Forrestal from 1969 to 70, so I have an intimate relationship, if you will, with this ship. This was my home during that period of time. We sailed the Mediterranean. No one knew we were on board. We dressed as sailors. We operated as sailors, but only 4 people, the admiral, the captain, executive officer, and weapons officer, knew that we were there. We looked like sailors. Everything we did was like sailors, but nobody could get into our spaces. We operated 4 nuclear magazines, 2 forward and 2 aft. The reason for that was that if one set of magazines was taken out of service for any reason, the other could fulfill the ship's nuclear mission. The Air Force forward Q areas were de-emphasized as ballistic missile submarines and supercarriers were commissioned. Each sub was 16 silo missiles, each carrier with 4 nuclear magazines as I described. Navy aircraft, except for bombers, demonstrated similar nuclear capability as Air Force planes, but from mobile forward positions. That is, they could sail anywhere the water was deep enough to handle their draft. Air Force heavy bombers were de-emphasized in favor of land-based and sea-based missiles. Small tactical, that is less than 1 megaton warheads, became focused as long-range accuracy improved and with inertial guidance improvements. Remember the frigate bird shot? It was within 2,000 meters of target. What the inertial guidance did was to drop missile accuracy from 2,000 meters to 200 meters. The second generation thermonuclear weapons. Many new advanced concept produced small and ultra-small lightweight warheads of high yield. This is where I came on board. This was the first weapon that I trained with. The Mark 28 was introduced in 1958 and went through several mods through the period of time that I was involved. Those of you who are familiar with the bombs of Palomares, Spain, there was a book written about an Air Force jet that collided with a refueling plane, and 4 weapons fell from it. One of them went into the ocean. There was about a 10-week recovery exercise that was an international incident. These were the weapons, Mark 28. So if you look at the cover of that book, you'll see what a Mark 28 looked like. Prior to that point, few people in the world even knew what an H-bomb looked like. And that picture will tell you that they were remarkably small. This particular weapon was a multi-purpose design. It was both tactical and strategic. It remained in the arsenal for 33 years. Its yield ranged from 11 KT to 70 to 350, 1.1 and 1.45 megaton, all from the same package. Now remember how I explained primaries and secondaries earlier? Now you have an idea of how that was done. This warhead was bomb, missile, and depth charge capable. For example, the primary. You recall what the primary was? This was the Mark 34 Lulu. It was an 11 KT anti-submarine depth charge. the same warhead went into the Mark 44 Astor, which was a wire-guided torpedo. I mentioned that a little earlier as a weapon that the attack submarines carried. Mark 43 was designed for high-speed, low-altitude delivery. This was a plutonium implosion device. Its yield was 70 KT to 1 megaton. It was retired in 1991. Its primary was used for the ASROC. This was the Mark 44 at 10 KT yield. You'll see the ASROC a little bit later, so take note of that. The Mark 45 was a new design from 1962. This was a multi-purpose, ultra-small warhead for tactical missiles, 1 KT to 15 KT. That is typically anti-aircraft missiles. The warhead was developed from the Mark 47 submarine-launched ballistic missile of 1960 and was deployed in SSBN submarines. The Mark 53 was the last generation large thermonuclear warhead designed for the Titan ICBM. It was an all-HEU. The yield was 9 megatons. As a bomb, it was carried as the B-53 of the same yield as the warhead for the ICBM. It was introduced in 1962, and it is listed as enduring stockpile. That is, they're still around. Okay, I mentioned ASROC to you. Now, you saw the frigate bird shot a little earlier. This is another important shot. 6 days later, on May the 11th, 1962, Swordfish was fired from the USS Agerholm, which was a destroyer. Okay, who wants to estimate the size of that missile given this superstructure from this ship? Anybody? What's the diameter? About? Anybody? A foot? Okay, that sounds good. Okay, how long is this thing? If it's a foot in diameter, it's what, 12 feet long or so? Okay, you're about right. It was about 15 inches in diameter. It's about 13 feet long, and it delivered 10 kilotons. What was Nagasaki? 20 kilotons, right? It weighed 20,000 pounds. This thing weighed approximately 370 pounds. So you can see the technological development of the weapons. Well, the Agerholm was the only destroyer to fire a live warhead missile. And those of you who have seen World War II movies, when the ash cans were rolled off the end of a destroyer and water came up behind to get that sub down below, that's what came up from 10 kilotons, and that's what it looked like, and that's what it went to. 10 kilotons was a massive underwater explosion at 650 feet in depth. October 1962, the Cuban Missile Crisis, this was after the frigate bird and swordfish shots, was a Soviet attempt to place nuclear missiles close to the United States that brought the U.S. and the USSR to the brink of nuclear war. 59 of 60 Thor IRBMs in the UK were placed on 15-minute of readiness, stood on their launch platforms, fueled, and prepared for firing with live warheads capable of reaching Moscow. These were Mark 59s at 1.44 megatons. Aren't we pleased that cooler heads prevailed? 1965. The assumed Soviet first strike was ICBMs across the Arctic, followed by bombers. The planned U.S. response was combined ICBM and submarine-launched ballistic missiles and bomber retaliation. Deployment anti-ballistic missile, or the ABM systems around Moscow and selected sites in the U.S. heightened nuclear threat. In 1966, the U.S. announced that it was deploying multiple independent reentry vehicles, that is, MIRVs, to overpower Soviet anti-missile capability. These were launched on the new Minuteman II ICBMs. However, MIRVs had been operational in the United States Navy since September 28, 1964, 2 years earlier, on the USS Daniel Webster, which was a fleet ballistic missile submarine fitted with 16 Polaris A3 or Mark 58 warheads of approximately 200 kilotons each. More second-generation weapons, just to give you a brief rundown. The Mark 55 was the small sub-rock warhead. It weighed 470 pounds. The evolution of the Mark 45 and the Mark 47 for submarine tube-launched rocket. Its yield was 11 KT to 250 KT. Now, what that means is that a submarine could detect another submarine from whatever distance and fire a tube-launched rocket that would break the surface, come back to the surface, and go after the submarine. Or that same rocket, if a fleet of enemy ships were detected, could launch a 250 KT explosion into the fleet on the surface. So this was the capability of the attack submarines. They were not listed as boomers, but they definitely were. 1957, the lightweight multipurpose tactical bomb and depth charge. It was a boosted implosion fusion to 20 KT. It was introduced in 1963. It weighed about 500 pounds in bomb form. It was less than 15 inches in diameter. 3,100 of them were produced. Okay, Mark 57, early 1960s, remember, 20 KT from Nagasaki, 1946. The difference was a completely deliverable bomb that weighed 500 pounds, had the same yield. Yes? Okay. The Mark 57 was replaced by the Mark 61. This was a multi-purpose tactical and strategic warhead for many weapon systems. Its yields were 0.3 to 340 kilotons, all from the same package. Introduced in 1966, the whole complete bomb weighed about 700 pounds. This weapon was 13.5 inches in diameter. It's the longest production run of any of the nuclear weapons, and it is listed as enduring stockpile. And there were many other weapons. The Cold War, to summarize, was nuclear detente, otherwise known as mutually assured destruction, or MAD. Weapons tests onboard delivery vehicles demonstrated the U.S. arsenal capabilities. By 1962, long-range stealth from the sea and ICBMs from land, anti-submarine nuclear capability from subs and planes. By the 1980s, there was stealth from the sky. Soviet commitment of 40% of its gross national product to its military was ineffective in response to the U.S. stealth technology. In 1991, the USSR collapsed, and the Cold War officially ended at that point. In March 26 of 1992, Russian presidential advisor Anatoly Rakatov stated, quote, "Over the last 6 decades, 80 to 90% of our national resources, our materials, technical, financial, and intellectual, have been used to create the military-industrial complex, and it proved ineffective." This is a summary. Remember Fat Man? This is listed Mark IV. Fat Man evolved into another one, 20 KT in man size. This was Bravo. The first image that you saw, that's the giant weapon. First phase of ICBMs and MIRVs on ICBMs. What you saw was a MIRV test in the South Pacific. This gives you a comparison. This is Nagasaki, 20 kiloton fireball. This is a 1 megaton fireball. This is set over San Francisco to give you an example of just the fireball. Okay, any questions?
We now do have some time for questions and comments. Do we have any questions and comments from the audience?
Yes.
Zia. Wait a minute. Zia. Use this microphone.
I was just curious, with all your work on the warheads and stuff, in the recent years, especially this current administration, has been talking up the use of anti-ballistic missile weapons. I was curious, how effective do you think that would be to defend against the stuff you worked on?
Well, if you do some rather basic calculations of the length of time from detection of a launch to wherever the target would be, that gives you your frame of reference. You have to do something within that frame of reference. The Patriot system has proven itself pretty effective. So the chances are those who have Patriot technology will be able to defend themselves against missile attacks, which is what the ABM is for. Those who don't have it, they're not going to defend. The reason for that is that if you have a projectile that's coming at you at tens of thousands of miles per hour, it's pretty hard to hit it, particularly when it's, you saw the relative size of a MIRV You know, if one of those things containing a half a megaton is coming at you, you just can't do much to stop it. Any other questions?
We have time for another question, but while you think about a question, we do have a question from the cyber audience. This comes from Dr. John Church, who is a frequent observer participant in our webcast. He's located in South Carolina. Please discuss the declassification authorization for the material in your presentation. When did the declassification occur and what was the motivation? As fascinating as the subject is, I wonder why material that was once declared top secret is now deemed suitable for declassification.
Okay. Everything that you've seen in this presentation is public domain. All the illustrations are from the National Archives, from military histories, U.S. Air Force, Strategic Air Command, U.S. Navy. Everything that I've compiled is independent of all classified. I use nothing classified in this presentation. So if you care to look on the internet, you can search on any of these subjects and you will be amazed at what you can find. So in terms of declassification, I don't know. I've been out of that loop since 1970. However, I have my experiences to draw upon. The fact that I was located at Clarksville Base for 2 years, one of the national warhead sites that's not classified. That site is the only one that's open to public scrutiny. You can go to Fort Campbell, Kentucky, and get a visitor's permit. Tell them you want to go to Clarksville Base, and you can go and look at the facilities where we did all that work. So I think the answer is all the classification was done independent of this talk, in that it's already, all of this, everything that you saw here is within public domain.
Okay, Dr. Ruggles, give him the microphone, please.
Yeah, hi. I keep collecting data on the total number of above-ground tests we've conducted. What's your number on that? How many do you know of?
I don't have that number here, but I have a listing just out of curiosity of all the tests.
Okay, I think, are there any more questions? One from Tom Scott, Dr. Scott.
You mentioned the airplane crash in Spain. Are there any other weapons that have been lost and not recovered?
Yes, there is. For example, there is. Okay, I should explain what a weapon is classified as. I shouldn't say classified. How they're listed. There are two categories. One is war reserve, and one is trainer. In the war reserve category, they have nuclear fuel. In the trainer category, they don't have nuclear fuel, but they are identical otherwise. That is, that the planes, pilots, rockets, whoever is firing these things can fire them, and they will operate just as a real weapon, that is, a trainer would. There are several weapons, and in one case, one off the coast of South Carolina that was listed as a trainer that apparently found its way into very deep mud and has never been recovered. The Goldsboro, North Carolina drop, if you will, a B-52 collided with a KC-135 refueling plane. Two weapons fell out of it. They were Mark 28s, the same that was in the Palomares. One of the fortunate design capabilities of these weapons is what's called a strike enabling plug. If that plug is in there, that weapon can operate. If that plug is not in there, it cannot operate because circuits are broken. These are very, very cleverly done, and one strike enabling plug is different from the other. They have to be properly matched and all that for the warhead to work, and this is part of the safing mechanisms. The firing sequence that a weapon goes through has to go through a very significant timing and in the correct order process. And the reason for that is to further improve safety. Well, in the Goldsboro crash, one of the weapons went through a complete firing sequence, just as it was supposed to. But its strike enabling plug was not installed, and it fell to the ground harmlessly and was recovered. The other weapon fell from about 6 miles in altitude and hit the ground with such impact that the friction separated the weapon from the outside in. And the core, being the smallest and the heaviest, kept on going, and that was never recovered. There was a site near Goldsboro. It's a farmer's field that has about 200 feet of concrete over it, and it's now part of the United States government's controlled land. There are some other weapons. The Thule, Greenland. Well, you'll have to investigate those. There's been a number of accidents in which weapons were involved.
Okay, let me make one final comment, and then we'll adjourn for the refreshments downstairs. I just wanted to point out that in this department and at this university, we focus on the peaceful uses of nuclear energy. But it is good and interesting to learn about the military applications of nuclear industry, of nuclear energy, and for that we appreciate your presentation. Now, before we adjourn, one of the ladies downstairs told me that in addition to the usual refreshments that we have, that somebody in this department has a birthday. And so there's birthday cake downstairs, and everyone is invited to the birthday party. So before we adjourn, let's express our appreciation to Mr. Gabbard for his presentation.